Hello, everyone. Welcome to our week 5. I hope you have received my message and also the course announcement for the week. And I hope you enjoy my pictures. Okay, so let me bring you some I really want to emphasize because the best thing for this week is we are going to make sense of all of this. That's so exciting, right? Okay, so let me share my screen. All right, so the first picture I'm going to share with you is this one. So that day, because my hike is in the Angeles National Forest, it's quite far. So I have to, pick up my friends and we drove there. It took us about like 1 hour. So, and also, the parking is really challenging in our forest. So we want to start early. So anyways, I got up. I left my house at 6:30. Yes, 6:30. This is the sky I saw. This is from my building. I'm living in an apartment, and I see that. Wow, that is such a beautiful sky. And I think you learned this type of cloud in one of our lecture. Okay, the moisture, water in the atmosphere, right? The cloud formation, and this one is called stratocumulus because you can see it's cumulus. You have a lot of cotton balls in the sky, right? And also all those cotton balls, they're in a sheet. So we call that strato. Strato means in the layer, okay? Cumulus means those cotton balls, okay? But with those palm trees, iconic, tree in Southern California, I think it's just so beautiful, okay? It's just so beautiful. My heart was melting. And here's another one on my hiking trail. You can see that's why I love our clouds. Here. This is a pine tree, okay, on my hiking trail, in our national forest. If you go to, actually, we went there for snows. We are chasing snow. On Friday, it's raining so heavily, and I was excited. Sending you guys a lot of messages. Sorry, but we know in the mountains, environmental lapse rate every 1,000 feet, you need to subtract normally 5.5, right? Fahrenheit. So LA is quite warm, it's like 60 something, but when we were up there, it's like 3,300 feet. So I think it's pretty cold. So you do the calculation. So we do see some snows on the top of the mountain, but not here. Okay, but because of cold environment, you have different vegetation compared to our Santa Monica. You can see you have a lot of those trees. I think it's a pine tree. It's a dead pine tree because of the wildfire. We see a lot of dead trees, the burnt trees on our hiking trail. So you can see the wildfire. That is, we are earthquake country. We also wildfire country. Okay. Anyways, this burnt tree background is another type of a cloud. You can see in the first module, you see everything together, right? Our Pachamama is such a wonderful system. Okay, this type of cloud, you can see it's like your hair, right? It's really, hairy-like and also uh, like very uh, how to say, like a lace or something, right? Okay, so this called cirrus cloud. This type of the cloud, cirrus, this type of cloud is really high in the sky. Okay, it's really high, and the temperature is very cold. Actually, the main component for this type of cloud is ice crystals. It's not a water droplet. It's unlike the cumulus cloud I showed you before. Okay, so you can see, you make sense of that. You learned so many things already. Okay, and here is another one. Let me see. Okay, this one is, all right, this is an overlook of our Angeles forest. Okay, so you can see all these rugged mountains. They are shaped by earthquake, and that's next module. But also I want to bring your attention to those clouds. This is the strato cloud, right? Stratus, you can see it's in layers. You see layers. Once you see this type of cloud, you know, oh, the air on top of the mountain, they rise together, right? They are not like our cotton balls, our cumulus cloud. It's here and here. You have those air parcel, right? Pocket of air rising up. You have this sheet cloud. That means the entire layer of air rising up. They together. Okay, and now you may have this question, why they rise all together? Our mountain, you may want to say that. Yes, our mountain is one of the reason those air can rise, because you know you have this lifting. That is the last module, right? When the air hitting the mountain, right, they all rise together. And you see on your windy.com the air from Friday, they from our ocean. We have that big high, right? High pressure on our ocean, and then the wind blowing towards the land. And when they hit the mountain, hit our San Gabriel Mountain, this place, they rise up, they form this type of cloud. See, that is why I love my air here. Because I can hear, I can listen, I can understand the story Pachamama is telling me. That actually is one of my professor. He told me that made me cry. He said, Jing, why we like, geography, why we like to study geography, because you will know every cloud have a story to tell. Every mountain have a story to tell. Every single water droplet have amazing story to tell. That made me cry. That made me fall in love with this discipline. I hope you feel the same as me. Okay, anyhow. And also we see those trees, and the rocks. And this, you can see this tree, the root insert into the rock. And this amazing root I see. Wow. It's just like people's bear, right? Like Santa Claus, he's bear like this. So you can see our biosystem, right? Interact with our lithosphere. They want to make soil. Those lichens, you can see, they are pioneers to make soil. You can see everything they're together. They bring, they're connected. They're connected. Okay. Anyways, I will keep sending you my hikes, the picture of my hikes. Okay. I hope this pandemic or lockdown can be ended soon. Okay. Everyone get vaccine and we can enjoy the nature together. Okay. I will send you the invitation when I was out there with other students. Okay. All right. So this is the first thing. I want to get started with our exciting week. Okay. And another one, I want to bring your attention to those two new modules, okay, we have here for this week. Okay. So this week we will have two modules. Okay. But your main work will be in this module number 6. We focus on understanding severe weather. Okay, module 7, we start a new sphere, our solid lithosphere. Okay, this will set up the foundation for the following module. That is, I labeled that wrong. That should be understanding our lithosphere and the deformation. Okay, geomorphology. So make sure you finish this one and start module 7 as soon as possible. Okay, and in module 6, you can see you need to study at least, okay, study the study guide and learning materials. Okay, so like last time, again, you need to download this study guide. Okay, let me save it here. Let me open it for you. Okay. Come on. Okay. Janet, do you still see my computer, my screen?
Yes.
Yes, wonderful. So you can see those are the main concept you must know for the sake of our quiz. Okay, and okay, you can see for each key concept, we have videos. Okay, make sure you must watch those videos and make sure you can understand, you can answer all these questions. Then you are ready for the quiz. Okay, so your textbook can also be a resources, but you need to at least finish this page. Okay, promise me, promise me. Okay, and today I will highlight a few things, a little bit challenging. Okay, but you will get it. Okay, so this is number one. Number two, okay, number two you need to do for this new module is lecture presentation. That's for me, lab. Okay, so here you go to this lab 5 that study the severe weather. You have two versions. I learned from some of your classmates. Some of them prefer PDF version, some of them PDF prefer the Word version. So I give you two. Okay, so you just need to download those two. Okay, so let's download this Word version. Oh, we can open it. Okay, so you can see here in this question. Okay, question 3. That is a live map. I downloaded on last Thursday when I was holding my office hour. Okay, we understand our live weather. Okay, so you can see the key to answer this question is to understand what's going on here. What's this? Okay, this called station model. Station model. Okay, so in your lab here, okay, I have a video to go over all the questions. Make sure you watched it. Okay, and this map can be downloaded here. To learn more about station model, how to read, how to make sense of those numbers around that station, that point. Okay, you need to go to the module number 6. You have a station model. Here we go. Okay, video 10, the station model, and I give you a practice. Okay, so make sure you watch this station model, this video. Okay, otherwise you will be confused. Okay. All right. Today I won't spend too much time on our lab, but on Thursday I'm going to hold extra office hour, same time, 5:30. Okay, and we are going to answer your questions. Okay. All right. Okay. So this is module 6. So again, you just need to finish your lab and take the quiz. Okay, take the quiz. For module number 7, you also have two things to do. Okay, you need to finish the quiz of the module. Okay, here is my decision. I know we have like 2 more weeks, right? I decide we don't have another essay because I know it's time consuming. It's a lot of it pressure on you, right? So we just have discussion and quizzes for this module and geomorphology, that module. Okay, so so take it easy. Okay, discussion is meant to give you this opportunity to explore, to explore the online resources to assist your study. Okay, there's a lot of resources. I don't want you to isolate yourself, in your small cubicle just to learn the content from textbook. That will be too dry. But discussion give you open this window. Okay, there's a whole beautiful world outside there you can learn. Okay, so take the quiz. Okay, discussion. Same thing for the following module. It should be module number 8. Okay. All right. Okay. So for this discussion, let me highlight something. Okay. First of all, we have a new due date. Okay. I will encourage you to start early. Okay. Because we have another module to do next week. Okay. So your first initial post is due on Monday. next Monday. Okay, and your response to your peers is due on Wednesday. Okay, next Wednesday. So again, you need to respond to your own group mates. Okay, encourage them to post something. I just want to create this opportunity for you guys to talk to each other. Okay, don't be strangers. Okay. All right. Okay, so what we are going to discuss on this discussion module, here we go. That is also inspired by you, by our hike, okay, to Switzer Falls on Sunday, okay? So first, since this module, we are going to learn basic rock types, okay? So the first question you need to answer, what's the main difference? Only one, okay? What's the main difference between igneous rocks, metamorphic rocks, and sedimentary rocks? Okay, and I want you to explore, to plan your own trail. Okay, go to all trails. Okay, this is my favorite app to find trails, and you can search, for example, Santa Monica, okay, mountains, national recreation area. Okay, and you can find the best trail, right? For example, we just go to here. This one is beautiful. Oh, this just just a picture, but you can see this is Solstice Canyon loop. Okay, there's a later spring Solstice Canyon will be here. That's one of my favorite. But let's see, you actually can click on this map. Okay, so for example, let's just go to this first one, Peter Strauss Run Trail. Okay, it's right here. Okay, so you can see, well, first, as a geographer, we need to locate where it is, right? It's in Malibu, and it's in the middle of our Santa Monica Mountains. It's very close to Agoura Hills, right? So the road right here is what? I don't know. Let's zoom in. Okay, oh, it's Mulholland Highway, right? It's in Mulholland Highway in the intersection with Tri Triumphal Creek. Okay, I don't know. Excuse my pronunciation. Okay, well, in the section of these. Okay, once you locate your trail, either you hiked it before or you plan to do, well, the next one is share the name with us, by the way. Okay, right here. Okay, and then when you hike out there in the middle of nowhere, you see many rocks, right? And you must have asked this question: who are you? Right? Rocks, who are you? What type of rock are they? So this discussion gives you this opportunity to know them. Okay, and the resources we are going to use is called geologic map. USGS, US Geologic Survey, they have this database called Geologic Map Database. Okay, so click on this map view, you will see a map. Okay, so you can see in this discussion, I have, the text highlighted with green, you must click on it. Okay, the yellow one means it's just FYI for your information. Okay, so let's go to this map view website. Okay, this is a better one. Okay, got you. All right, so let's zoom in to Los Angeles, to Santa Monica, to our beautiful Malibu. Okay, and you can see, oh, it's more or less, I think it should be in this area, right? Okay, so Agoura Hills, Malibu Creek. Yes, this is the highway. This is the highway. I think that is, let's see. Oh, it's flowing to this beautiful lake, and this is Malibu Lake, right? Okay, so we are here. We actually found it. Okay, so you can see this is the lake. So your trail actually is about in this area, right? Okay, so when you find your trail, you can see, you can click on it, and you will find this geologic map. Okay, and you just click on this button called More Info, and then you will go to the database and you find your map. Okay, how easy it is. And then you just need to click on this image that can blow up your image. Okay. All right. And then let's see. We go to the lake. Okay. It's about, let's see, where's the lake? Okay, we need to go back. Okay, so this about in this, let's see, you zoom out a little bit. Okay, want to go here. Okay, so you can see this red line. That means the edge of your geologic map. Okay, so you can see our location is to the upper right corner. So let's go back to our map. Okay, I should blow up in this area. See our lake, right? How easy it is. So your trail will be somewhere here. Okay, and you can see, oh, in this area is a lot of labels. You can see all these labels, something TCVA, TCVB, TCVBP. I don't know what's this. Those are the geologic unit labels. Okay, this actually tells you rocks, who they are, what type of rock it is. How you find it, you just need to go to the sites. Okay, let me zoom out a little bit. Okay, TCVA, right? TCVA right here. Okay, so you can see TCVA, TCVB, this formation, and Conning Hole, volcanoes, extrusive rocks. Those rocks actually from volcanoes. How amazing it is, guys. Okay, and then you can read over here, and you can also find when they was formed. You can see Cenozoic. In our lecture, you will learn what is Cenozoic, right? Okay, what is Miocene? Okay, how old are you? Right? So you can see you can get so many information from this single map. And then when you learn it, you can see here I have a few questions just to show you how to do this. This is for my hike, Wizard Falls. Okay, you need to answer this. You need to record the label. Okay, what are the labels in your area? And you need to sort which one is younger, which one is older, how old your rock are. Okay, and then share with us all these 4 questions. Okay, what are type of rocks, sort the age, write up the rock formation process. Okay, because you are going to learn different rock, they're formed in different way. Okay, here I blow it up, emphasize, do not Google it. I appreciate you, not Google. Okay, I want you to form this story with your own words. Okay, and you will need to refer to the 3 basic rock formation process: igneous, metamorphic, and sedimentary. Okay, that's in my lecture slides, also on your study guide module. You will see that. Okay, so here is just a example for my hiking trail. I learned that those 2, one is granite, the other one is Gabriel. Okay, they both igneous rock, and I can tell the story. And then they are this million years old, and I'm amazed. Okay, so this discussion. I think I enjoyed it. I don't know about you, but I enjoyed it. Maybe I'm a nerd or something. Anyways, okay, I hope you like it and to explore. Okay, stay curious. And when you finish, make sure you reply to your group mates. Okay, again, disagree or agree his or her interpretation of the rock formation process. Okay, why not point out any other mistake if they have, okay, in their initial post. Okay, so make sure you catch the deadline. All right, okay. John A, do you have any questions about this?
Not yet.
Okay, sounds great. I hope you enjoyed it. I was so excited. Sorry. All right, so let me close all this. Okay, and let's go back to our module number 6. Okay, so lecture presentation. Okay. See, I also highlight the key concept here. Okay. The first one is your air mass. Okay. So let me go back to this air mass. Okay. What is air mass? Air mass, I want to emphasize, is unlike our air parcel we learned in the previous water in atmosphere, that section, that lecture. Okay, air mass is large. Okay, it's a large mass of air. Okay, with relatively homogeneous characteristics. Okay, so one is large. They together, they're like a troop. You know, a group of soldiers, troop. They move together. They move, travel as one. Okay, and they have uniform temperature and humidity. Okay, so that is why we can use temperature and humidity to label them. Okay, so you can see here CA, CP, MP, CT, MT, MT, right? Those labels, two letters, right? One indicate moisture, the other one indicate temperature. Okay, so you can see those are the letters. C means continental, indicating that air mass is dry. Okay, because that air mass, the source region where it was formed, okay, it's from a continent, and you know continent is relatively drier, right? Okay, and the other one is maritime. It's indicating the air mass is moist. See this one, MP, it formed in our Alaska Bay. Okay, here north part of the Pacific Ocean, so it's maritime. Okay, so the first letter must be smaller case, okay, indicating moisture. The second letter must be uppercase, indicating temperature. Okay, so you can see PTAE. Okay, P is polar, means cold. Okay, T means tropical, means hot, right? Okay, A means Arctic or Antarctica in southern hemisphere. That means extremely cold, right? Okay, and equator means super super hot, right? Okay, you know you can sort it, okay, by temperature. So again, the second letter must be uppercase, indicating temperature. Okay, so that is your air mass. In your lab, you are going to label, you know, differentiate different air mass. Okay. Okay, so this is the air mass globally, and the air mass, they travel. Okay, they will be blown by our weather system, by our wind. Okay, so you can see this is in general, you know, how they move. You can see in our winter, you know, snow lake effect, right? In New York State, okay, Michigan, in wintertime, they have a lot of snow. Even now during the, you know, climate change, this morning NPR, if you listen to NPR this morning, they don't have much snow, lake snow, because climate change. So, but anyways, those lake snow, they are created by those air mass, you know, Arctic air mass, continental air mass move over those Great Lakes, pick up the moisture, okay, they dump a lot of snow, okay, on the other side of the lakes. Okay, so anyways, when the air mass, when they move, they will be modified by the, you know, subsurface, our ground or our ocean. They can become, you know, drier or moister, or you know, warmer or colder. Okay, so don't think their original property, the label, never change. It changes. It will interact with our ground, with our ocean. Okay, so you can see that can give us this snow lake, lake snow, sorry, lake snow effect. So you can see those are the Arctic, you know, region, the air mass or continental CP air mass. This one, okay, continental polar air mass. It's quite dry, right? Continental, but when they move over the Great Lakes, they will pick up the moisture evaporated from the lake. Okay, and because the air mass is cold, and you know cold air cannot hold that much water, so they will get saturated, and then they will dump a lot of snow on the other side. You can see the other side of Lake Michigan, right? The other side of Lake Erie, forgot. Sorry, in New York State, right? Pennsylvania, this part, Ohio. Okay, you will have a lot of snow. Okay, and yeah, this is called air mass modification. Okay, there's another key concept. Johnny, ask question if you have any. Okay.
Okay.
All right. So this is a good workout when I was in Madison every winter. You know, you need to dig your car from the snow due to this lake snow effect. Anyhow, good memory. Okay, so why we need to study this air mass? Because when the air mass, they move, especially when they are lifted, like the elevator, okay? They are lifted to the sky. You know, from last module, when the air rising, it will get cooled, it will become saturated, it will give you rain and snow, right? So we are going to learn how we lift up those air masses, okay? The first one is called frontal lifting, okay? Last week, when we studied the global wind belt, you learned this already. We have that polar front, right? In the lecture, we know that we learned that you have the warm air from subtropical region, right? You have cold air from the polar area. The cold air is like an elephant, it's like a heavy duty truck, right? Very heavy, they don't want to rise. But the warm air, they're fluffy, they're lighter, they're going to rise. So this is called frontal lifting, okay? And this interface between your warm air mass and your cold air or cool air mass is called front. Okay, it's called front. It's another key concept. Okay, we have two types of front. We have cold front, we have warm front. Actually, we have stationary front and also the occluded front. I will leave that for you to read in your textbook and also your study guide page. Okay, but here I want to highlight those cold front and warm front. Okay, cold front, remember, when we're talking about front, you must have two different air masses. Okay, it's not cold air or warm air, make sure. Okay, you know this. So the front is two different air mass, they collide. If in this collision, okay, your cold air mass is stronger, is more aggressive, okay, like this way, like this picture shows you. It's very heavy duty, okay, it's very, very aggressive, moving to this direction to the right of your screen, okay. Then this one is called cold front, and we use this, sharp triangles to indicate, oh, that's a cold front. Last Friday, there actually is a cold front pass our Los Angeles, okay, dump a lot of rain and snow, okay. So you can see behind, this triangles indicating to which direction this cold air want to move to, okay. So you can see behind this front, you have cold air. In front of that, you have the weak warm air, okay. And you can see because the cold air is very, very strong, the warm air will be forced up almost vertically. So you will end up with this tower cloud. Okay, I didn't see that on my hiking trail, but sometimes, especially in the summertime, okay, you will see over our Angeles mountains, okay, you will have a tower cloud. That may be due to frontal lifting. You have cold front moving in, okay, or over our ocean. Okay, our air rise up vertically because this interface, this front slope is very, very steep. Okay, compared to that one, you also have this warm front. You can tell now it's just opposite. Okay, in this collision, two different air mass, you have the warm air stronger, cold air or cool air weaker. Okay, so you can see the warm air actually move aggressively, okay, towards the cold air and glide up slowly, okay, because the warm air is fluffy, right? They're very light. They just glide on top of this relatively flatter, okay, front slope, okay, and they will create different type of cloud. You have this stratus cloud. Okay, the stratus cloud I showed you at the beginning of this lecture, right? I say this could be pushed by our mountains, could be also a warm front. Okay, entire air mass they're lifted together, they get lifted together. Okay, and then when they go up, you will have this altostratus, means in the middle level, right? Cirrostratus, okay, a little bit higher, and then dissipating to cirrus cloud, the hairy like cloud I showed you before, right? Okay, so you can see this is a different type of cloud, different type of front. You have strong warm air push against weak cold air, and warm air wins. So the semicircles indicating, oh, to that direction, our boundary between warm and cold will move into that direction. Okay, so direction matters. Okay, and different precipitation, different rain you will see. In this case, because the warm air, they just take time, to rise up. You will have very long-lasting rain. Okay, it will rain maybe 1 day, 2 days. Okay, maybe several days. Okay, but for this cold front, you can see the air, actually warm air, rise up rapidly. Okay, abruptly, very fast. So you have very intense shower, but it won't last long. It may be hours, it just gone. Okay, like last Friday, right? We just rain maybe in the morning, half day, right? And in the afternoon, it's sunny. Okay, it's sunny sky. So this is the different fronts you need to know. Okay, so there's another, summary about cold front and warm front, their difference. Okay, and usually on our weather map, on our satellite image, you also see those two fronts, they hooked up. Okay, you have this like a lambda, this ladder, okay, this shape. You can see this is the cold front, this is a warm front. Okay, and here is another one. You can see this is your cold front, this is your warm front. Okay, what's this guy? What's this monster? Okay, this actually bring up a lot of, winter storm, especially in the middle part and east part of this country. Okay, what's that? Mid-latitude cyclone. Okay, mid-latitude cyclone. Mid-latitude just indicate where it formed. Mid-latitude, we are talking about 30 to 60. That is United States. That's also China. That is also, Europe. Okay, that is mid-latitude. So all weather actually affected by mid-latitude cyclone. Almost every day we have it. Okay. So how it was formed, that is the question. Okay. As you can see, it's a cyclone. Cyclone, you always have the low at the center, right? Low pressure. So because it's a low pressure, it will draw in different air mass because it's mid-latitude, right? From the higher latitude, you will have cold, dry air. From the lower latitude, tropical region, you will have warm, moist air. Okay, like I showed you here, you have this low, let me annotate. You have this low right here. Okay, from the north, let me change the color. You have this cool air, CP air mass, right? Continental polar air mass drawing in. From the south, from our Gulf, you have this warm air drawing in, right? Okay, but I'm wrong here. Coral is first. We need to consider coral is first. Okay, our air cannot move this way. Let me go back. Okay, you want to go this way, but it will be deflect to the right. See, you follow the wind, we go that way, right? Okay, and here you can see this cold air cannot go directly to the low, right? Let me erase that. Erase this, okay? Let me change the color. Okay, oh, all right. So you want to go this way, but you will go this way actually. We follow the air, we turn to the right, from last module. Okay, so you can see, well, I can draw another one. Okay, you have very weak cold air from this area, but not significant. But you want to go this way, right? But you need to deflect this way. So let me undo. It should be go this way, right? Okay, so you can see around this low, you will have what? Let me use the black one, okay? You will have two boundaries. One is here, okay? The other one is here. You can see if you draw those boundaries, you can, divide your space into two sections, right? Down here, they all warm. We call that warm sector. You will label that in your lab, okay? And then up here, we call that cold air sector, cold sector, okay? And then you can see if you're standing here along this line, your cold air is very direct to this line, right? Okay, means this cold air is stronger. Okay, relatively, you can see the warm air got deflected away, so warm air is weaker. So along this line, you must have this cold front, okay, because your cold air is stronger, it's more direct. But up there, you can see towards this boundary, you must have a warm front moving that way. Okay, so now you know why we have those two. Okay, why we have those two, because of this. Okay, always like this spin. Okay, several things. My former student, they made mistake. Okay, those two fronts, they won't, spinning all over 360 degrees. Okay, because this cold front will move faster. Okay, maybe in like one day, it will catch up your warm front. So those two fronts, it's just like your zipper. I have my hoodie here, your zipper. Okay, they will zip up together. You will have another front called occluded front. In that case, your warm sector, the entire air will be lifted up. Okay, totally separate from the ground. So that's what we call occluded. And then your mid-latitude cyclone will die. Okay, so that is the thing. That is the formation of this mid-latitude cyclone. Okay, Johnny, do you have any questions?
No, I understand what you're saying.
Very good. Amazing. Okay. All right. So this basically is animation to show you how it formed. And you can see this is the final stage of this occlusion. Occlusion. So you can see starting from here, your cold front will catch up your warm front. Okay, and they will merge together. Okay, they zip up together. And because your warm air mass is fluffy, it's lighter, okay, they want to rise up. Okay, so you can see here, warm air totally get lifted. Okay, so this is called occluded front, and your cyclone just died. Okay, so that is the life cycle of your mid-latitude cyclone. It can last, several days. Okay. All right, so here we are very interested in this stage. So in your lab, in your quiz, you will have this question about this stage. Okay, cyclone circulation established. We call that open stage. So no occlusion happened yet. Okay, so you will have an established cold front, established warm front. Okay, and then you're going to tell what kind of weather you're going to see along each front. That becomes simple as long as you understand cold front, warm front, what kind of weather you're going to see. Okay, so you can see here, this is the weather map. Okay, we have this established open stage mid-latitude cyclone. Okay, so cold front is here, warm front is here. Okay, and I have this line called line of cross section, means I cut this map from the sky to the ground. Okay, and I show you a cross section view here. You can see this is your cold front. Okay, it's very steep. This your in front of it is a warm front, and together they all move this way, right? Because your cold air is more aggressive. here your warm air is more aggressive compared to this cool air. Okay, and you have different cloud along different fronts, right? And as long as your air is rising, you should see air pressure is dropping. So that's why here, let's see, this one. Let's see, post warm sector. Okay, so here you can see this low steady, okay, means here, okay, in location, for example, this location, okay, because the air is rising, is pushed up, your air pressure actually is low, okay, but behind your cold front, like here, okay, because this place, like A, corresponding to this place, okay, totally controlled by cold air, right? Cold air is heavy, so you can see the air pressure is rising, is increasing. Okay, so this is how you tell air pressure change. Okay, if you see the air rising, you must see dropping, decreasing air pressure. Okay, if the air is sinking, is descending down to the ground, then that is a very high pressure. Okay, and well, if the air is cold, then that is a high pressure. If the air is warm, then that's low pressure. Okay, so in your lab, you have a question to tell the pressure. Okay, bring your question on Thursday, and I will address them. Okay, but this is the key to answer those questions. Okay, so this is the mid-latitude cyclone. Then after that, we are going to learn all the severe weathers. Okay, the first one is called thunderstorm. Thunderstorm sounds very, very scary, right? But the formation is quite simple. Okay, when you have a thunderstorm, what do you experience? It's a very short but very intense shower, right? That actually due to our air, a bubble of air, a parcel of air rising up abruptly for whatever reason. Okay, can be mountain lifting, can be frontal lifting, can be other lifting, they rise up like this. Okay, but in thunderstorm, you also have thunder, you have lightning, right? Why is that? Because this rising parcel of air must pass this temperature line, okay, 0 degrees Celsius, 32 Fahrenheit, okay, 32 Fahrenheit. So once you pass this freezing line, means what? You're going to have snow. You have going to have ice in your cloud, right? Happen to be like this. Your snow, solid water, okay, and your ice crystals, they carry positive charge. Okay, so basically in this cloud, on top of this cloud, for example here, you have snowflakes. Snowflakes is lighter, right? They rise up, they will carry the positive charge. But when those moisture, when those water droplet, they get too heavy, okay, they will falling down, right? Those liquid water, they actually carry negative charge. So in this one tower cloud, you will have the separation of those different charges, positive and negative. So what? Your tower cloud actually become a battery, right? The positive charge and negative charge, they want to neutralize with each other, right? So then you have lightning. Lightning is just those you neutralize different electric charges. Okay, and because at the bottom of your cloud you have negative, ground you will call out positive. Okay, here is positive. So again, your cloud base, your lifting condensation level, okay, the flat bottom of your cloud and the ground also have these different charges, electric charges. Then you have another lightning. Okay, so that is the lightning formation. Then you also have thunder, right? Why you have thunder? That is this electric energy break through the air. Okay, you will ignite the air molecules. They will make sound. those energy will make the sound happen. Like here, I rip off a paper, for example. Let me find a paper. Let's see, like this, okay? I want to rip off paper, okay? Listen, right? So my energy, I rip off this paper, you hear the sound, right? So that is the energy breaks through the air, will, excite the air in between. Does that make sense, John A. and Ifeani?
Yes.
Yes, wonderful. So you can see here you have 3 stages. Okay, when it's all the air rising, they have cumulus. Okay, and mature stages, you have this rising and downpouring the rain. Okay, we call that downdrafting. Okay, you have this mature stage, and then the downdrafting stage dominate. You have this dissipating stage. Okay, exciting. All right. Okay, so then this tower cloud actually sometimes is quite scary. If the rising air is very high, okay, they can shoot over your tropopause, troposphere, the the bottom layer of your atmosphere, right? You have a tropopause, but sometimes your rising air can shoot over your tropopause, okay? So you have this overshooting top, okay? So when your rising air is super, super strong, okay, we call this thunderstorm severe thunderstorm, aka supercell thunderstorm, okay? And as a result, your downdrafting, you can see rising air is very strong, your downdrafting is also very heavy, okay? So it's just like you pour a bowl of water on the ground, okay? You will have a lot of those gust wind, see, this gust wind, okay? This actually is one way to form tornadoes, okay? Later I will show you in the next slide, okay? But supercell thunderstorm, as you can learn from one of the video on our study guide page, okay? That is our NOAA scientist, tornado scientist. He studied many tornadoes is triggered by this supercell thunderstorm. It's like a monster, okay? All right, so I covered this already, lightning and thunder, okay? And as a geographer, we always curious about spatial distribution, right? In the previous 2 essays, you learned it. So where you have the higher values, where you have the lower values. It's pretty easy because you understand how thunderstorm was formed. Then you know you must have rising air. Then if a place have a lot of rising air, you will have a lot of thunderstorm, right? You have a higher chance to have thunderstorm. So that is why we have this map. So you can see for Florida, we have a lot because warm air, they rise a lot, right? Okay, here in Colorado, in front of our Rocky Mountains, okay, New Mexico, okay, Arizona, you have a lot, okay, Texas, you have a lot. Well, that is when the air from the Gulf, warm air from the Gulf, they move this way, right? Okay, and you have mountains here. That's our Rocky Mountains. Okay, Colorado Plateau. Okay, the air will rise, so you have more thunderstorm happening over here. Okay, our area actually we have very little chance because our air, like I draw this line, this actually the cold ocean currents. Okay, California cold currents. So that will stabilize our air. Our air don't want to move. We don't want to rise. But of course, we have mountains. Mountains will push up our air. Sometimes you also have thunderstorm in our local area. But compared to other region, we have less chance. Okay? Does that make sense?
Yes.
Yes.
Yeah.
Okay. As long as the air is rising, right? Okay. All right, then tornado. Why we have the tornado? Tornado, you see a lot of pictures about that, right? Like a funnel cloud, how that form. That is all because you have this super fast, the spinning, It's super, super fast. It's just like your blender. You actually can create a tornado in your blender, right? The spinning is super, super fast. And then you have this funnel cloud at the bottom. But at the beginning, it's not a vertical, swirl. It's a horizontal. How that happen? That actually we call that wind shear. It can be triggered by your supercell thunderstorm. Okay, you can see when the downpouring air, they hit the ground all suddenly, they will trigger those, ripple, right? Or the turning. So at the beginning, you will have this horizontally turning column of air, okay? Or upper level air moving faster. You have jet stream moving very fast, and the ground level, the wind moving slowly because of friction, right? So you can see if they move to the same direction, okay, upper level moving fast, lower level moving slowly, you will also twist your air, right? Just like your pushing pin or something, right? You can rotate your air. So that is the first stage, okay? Second stage is you have this horizontally rolling air got caught up, okay? Got caught up by the updraft, rising air. Can be any reason, can be a warm air, can be mountain, can be front, right? So the rising air, this supercell thunderstorm will turn this column of air all of a sudden to the vertical, okay? And they spinning very, very fast, okay, because it's rising air. And then you will form tornado, okay? So does that make sense, guys? Any questions? Sounds good? Okay, all right, so that is horizontally rolling air turning to the vertical by the supercell thunderstorm, okay? Or can be other, rising air lifting mechanism, okay? So you can watch this video to I think the meteorologist, the tornado expert, he explained here, okay? And you can read over here. All right, then where it happened, right? In this case, you don't have many in Florida because the warm air, they rise by themselves, right? Okay, the rising won't be strongest enough to create tornadoes, but in our main the Great Plain area, okay, in the middle of our states, okay, you have the mountains right here, okay, they will push up the rolling, the column of air, they will rise up. So that's why you see here is a lot, okay, along Mississippi River, Middle East is there, Middle West is a lot, okay. So that is tornado frequency. Okay, so watch the video. I think I have a video. Oh, this one also actually explain why you have so many tornadoes in between. The terrain is the key. Okay. All right. So the last but not least, that is your hurricane. Okay. Hurricane is also a low pressure. You see this hole. This actually is a very, very low pressure. Okay. Well, hurricane also called tropical storm or tropical cyclone, okay, in different area, okay. Well, tropical means it's only formed over tropical ocean, actually, only tropical ocean. So don't, confuse with our mid-latitude cyclone, okay. That is mid-latitude, this one is tropical, and this one is much smaller than our mid-latitude cyclone, okay. So you can see because this low pressure is super, super, super low, okay, will very aggressively drawing in all the warm air nearby. Here we'll just talk about one air mass, your tropical maritime MT air mass, okay. Drawing in coral, this force will turn this air like a spinning, it's like your blender, right? Okay, and the air will rise because it's low pressure. They will rise very, very fast, okay, and you will create those band of cloud, band of rain, okay? And the strongest rising actually is very close to this eye, not at the eye, okay? We call that eye wall, the most inside one. You have rising cloud, okay, rising air. You have a lot of thunderstorm and maybe tornadoes, okay, in this part, okay? And this, like I mentioned earlier, our hurricane is mainly powered by our warm ocean, right? It's just the warm air they want to rise. They are drawn by this low pressure formed over our warm ocean. So that's why recently you have more and more tornadoes because climate change, global warming, our ocean temperature is rising. Okay, so that is why now almost all year long that is a hurricane season. Okay, in Florida they worry a lot. They worry a lot. Okay, so you can see this the autonomy of your hurricanes. Okay, this is the eye in the middle because your air can never get there. They will rise up totally before they get there. So in between you have this hole. There's no cloud. There's sunny sky in the eye. Okay, but the strongest rising is on the eye wall. Okay, in the eye wall area. Okay, and you have multiple rain bands in the air. They can't wait to get to the eye wall to rise. They will have these rain bands. Okay, very beautiful. So like I said, in order to create a hurricane, you want to have SST, sea surface temperature greater than this temperature. Okay, you must have this temperature. It's about like 60 something Fahrenheit. Okay, and then you must have this ITCZ. ITC, the air, they merge together, they want to rise, right? Initial disturbance, make the air rising. And also you want to have Coriolis force, okay? Because the air want to spinning. So that's why when you see this frequency map, you see this gap along equator, because along equator, 5 degrees north, 5 degrees south. In this narrow band, you don't have Coriolis force. Okay, so that is why. And this is the season, hurricane season. You can see it start from late May, early May. Okay, well the peak in September. Okay, and then it will end towards December. So the second half of the year. But now because the ocean is so warm, almost all year long you see a lot of hurricanes. Okay, and the last but not least, that is the air want to rise, right? Want to rise, go all the way to the tropopause. You don't want this wind shear. Okay, upper level wind and lower level wind, you have different direction, different speed. No, you don't want it in this case. Okay, but in tornado case, you want it. Okay, and this is how we classify your hurricane, different category. Okay, category 5 is the strongest. So 2005, if you're old enough to know 2005 Hurricane Katrina, okay, it's a totally disaster. Okay, devastating events hitting New Orleans. Okay, hit our Black community so hard, right? Especially hard. So you can see, yeah, I know this month is a we celebrate Black History Month. Okay, let's memorize. Let's get memorize all these, the tragic events, okay, hurt our Black communities. Okay, Hurricane Katrina is one. So we have this question in your lab to study Hurricane Katrina, how it was formed, and how it like dissipate when it hit New Orleans. Okay, so again, our Earth system, including you and me, we are part of it. Okay, we're not just ourselves. Don't be that selfish. Okay, you're one key component of our Pachamama. Okay, we are in this system. All right, so why Hurricane Katrina? It's such a destructive event to New Orleans, to our Black community, because you have this storm surge. You have heavy rain, of course. You have very strong wind, of course. But the most dangerous one is this flooding, coastal region flooding. Okay, because you can see this eye is a very low pressure that, like your vacuum, will suck up the ocean. You can see this is the ocean. So you will have this big surge of wave. Okay, if you ever swim in the ocean, you know the waves sometimes can be very, very tall. Okay, and then when they hit the coastal area, they will slap on the beach on your in your coastal region in our into our cities. Okay, you will have this flooding in your city. This actually is the most dangerous one. Okay, that is a disaster. Okay, to our communities. Okay. All right, so this is the hurricane. So we study three types of severe weather: hurricane, tornado, mid-latitude cyclone. Oh, sorry, and thunderstorm. Okay, 4. You want to understand why they are formed, okay, in which condition, and how they evolve with time. Okay, the life cycle of different weather events. Okay, and what energy source, like hurricane is powered by our warm ocean. So that's why when the hurricane hit the ground, they will dissipate, right? Okay, and the energy source for our mid-latitude cyclone is, different fronts. But when you have this occluded front, you don't have any fronts. You don't have fronts anymore. So mid-latitude cyclone will die. Okay, so study that, focus on that. Last but not least, I want to briefly introduce you this station model. Okay, this station model. So you can see, you can go here to read more. Okay, that's from our NOAA website. But you can see here this circle, that is fixed, never move. That indicating one weather station, like the one in Ventura, the one in LAX. Okay, it's fixed. But surrounding here, you have different numbers and symbols. Okay, they indicate different things. So for example, this one is temperature. Okay, our weather map is in Fahrenheit. Okay, you have dew point temperature. Okay, sometimes we shade this circle. We call that sky cover. Okay, if you totally shade it completely, that means overcast. Okay, and then here on the left side, you have sea level pressure. Okay, how to convert this number? This number, by the way, is not the final air pressure reading at the sea level. Okay, it must do this. Number 1, you need to divide the number by 10. Okay. Number 2, you want to put two numbers, not add, by the way, okay, in front of the result from step 1. Okay, so let me demonstrate what do I mean by that. Okay, so you can see, let me change the color. Okay, so for this one, for this number, right, divide number by 10, you got what? You got 10.7, right? And then you want to put two types of numbers in front of it. Okay, what are the two numbers? Let me use this black. Okay, one is 9 in front of it. Don't do add, just put 9 in front of it. Okay, and the other one is 10, okay, in front of it. In this case, you will have two results. One is 910.7, right? 910.7 millibar. The other one is 1010.7, right? And then step 3, you're going to compare. Let me change the color. Text. Change the color to blue. Okay, and number 3, you're going to compare the two numbers from two results from step 2 with mean sea level air pressure. Okay, mean sea level air pressure, which is 13.25 millibar. Okay, see which one is closer and choose the one closer to MSLP. Okay, so in this case, you can see 1010 is closer to 1013.25 millibar. So this is your answer. Okay, 1010.7. Does that make sense, John A. and Ifeani? Yes. Okay, divide. Okay, put 9. Yeah, go ahead, John A.
I was just I didn't mean to I was just calculating, sorry.
Yeah, don't do add. Don't do adding. Okay, just put 9 and or 10 in front of it.
So you
Okay.
don't add it together?
No. Here, you first divide 10. Okay, you first divide 107 with 10. So you get 10.7, right? Yes?
Yes.
Okay, then in front of it, you put 9, then this number become 910.7. Right?
Okay, I see.
Okay, and the other one is you put 10 in front of it. Okay, 10.7. Then you get two results. You just compared it to, 1013.25. Don't overthink. There's no calculation here. All right, so this is the mean sea level pressure, and the other one, this one is pressure change in the past 3 hours. Okay, but again, as long as you're dealing with air pressure, you need to divide it by 10. So this -6 actually is not -6. You need to divide it by 10, so that's 0.6. That means in the past 3 hours, your pressure decreasing, like this symbol shows you, decreasing and stay stable, okay, by 0.6 millibar, 0.6 millibar. Okay, so you need to divide it by 10 as long as you're dealing with pressure. Make sense? Yes? John A? Yeah, Infinity, I see you. Yes, I see your code in the
Yes.
chat. Yes. Okay, wonderful. So I think that is the most difficult part for the station model. Okay. All right, I believe this is the last slide. I think I have go over all the key concepts. So you're brilliant. You're brilliant. So if you get all the concepts, maybe roughly like 70 or 80%, you're wonderful, wonderful. Okay, but this lecture is recorded. Make sure if you don't know any key concept, I highlighted here. Okay, also I give you the page of your textbook, okay, to read, and also your study guide page. Okay, make sure you watch those videos. Okay, so that is the key to finish your lab and also your the quiz. Okay, so let's focus on this. Ideally, you finish the module by Friday. Okay, ideally by Friday, and then over the weekend you can start a new module to study the Earth's interior and rock cycle. You can, use this discussion to get started. Okay, and on Thursday I will give you a brief start of this module. Okay, and that meeting will also be recorded, and I maybe just use like 20 minutes. Okay, and then after that we can, answer your questions. Sounds great.
Sounds good to me.
Okay, I will see you guys on Thursday. Let me stop share and stop